Angles can be classified according to their size. If you have a look at this diagram, you'll notice that there's a fairly small angle here, and we can enlarge this angle by rotating it around all the way to 360 degrees, which makes up a full circle. So this particular angle can be rotated right around 360 degrees. Now when it comes to defining angles, the main thing to remember is there are a couple of key positions for angles. For example, this 90-degree positioning of an angle is very important, just in here. This is a 90-degree angle with a 180-degree angle, a straight line right around. Down underneath the diagram is a straight line, which we know is 180 degrees. And around here, this bottom angle is a line that can be rotated right round 360 degrees right back to its original position. Now, all the angles that we talk about can be defined depending on the position relative to these points. For example, when we work with what we call an acute angle is an angle somewhere between 0 and 90 degrees. So there it is there, an acute angle. Let's position it here. So I can take a pen and mark it in here as an acute angle. An acute angle is an angle, and let's say we'll call this angle X. X is bigger than 0 degrees, and X is also less than 90 degrees. So there's your acute angle. The next type of angle we get is one that goes beyond 90 degrees. So we've got our 90-degree angle there, but if I go beyond 90 degrees and down as far as 180 degrees, I end up with what we call an obtuse angle. So let's position the obtuse angle there, and I'll just get rid of this one, just so that it's not in the road. And we end up with an angle bigger than 90, but less than 180 degrees. So we'll define this as our obtuse angle. So if we call this X, we now have X bigger than 90 degrees, but it is less than a straight line, or 180 degrees. And illustrating it over here, if I take this back to 90 degrees, and you can see by the little numbers down there, 90 degrees, I can expand this right round to 180 degrees, and I've got my obtuse angle. So the one that we're looking at over here is about that, maybe a little bit more. So it looks like it's about 150 degrees maybe, but it's definitely between 90 and 180 degrees. Once we move beyond 180 degrees, we get what we call a reflex angle. Now reflex angles are fairly big. They can go from 180 degrees right around, but they must be less than 360 degrees. So they can't make up a full circle. So if I go to here, for example, I can make up a reflex angle that goes right around here. Like that. There's our reflex angle. So what we might do is we'll get rid of this part of the straight line. So you can see a reflex angle here. So let's define our reflex angle as being, and once again we'll call it x. X would be bigger than 180 degrees, but x must be less than 360 degrees. So I guess we could try and find out approximately how big this angle is here. If we move it around on the diagram to about its position, it'll help us. That maybe about there. It looks like it's about 310 degrees right around this way. The final angle, which almost doesn't seem like an angle, is what we call a revolution. And I think you'll find that that's pretty self-explanatory, because you've got a ray that moves right around 360 degrees. So there's our revolution. So here we go, right around. There it is. And this is x, equal to 360 degrees rotation, and we call this a revolution. And on the diagram, that would simply be meaning we complete the circle right round to 360 degrees, and we have all our angles. So let's go back over it. You have your 90-degree angle. Between 0 and 90 we have our acute angles. If the angle goes beyond 90 degrees but less than a straight line, or 180 degrees, we have an obtuse angle. If the angle goes beyond 180 degrees but not right around, we have a reflex angle. And finally, the angle that goes completely around, because it's a full circle really, we call that a revolution, which is what we have as a circle, an angle here. That is a revolution, 360 degrees.